Alright, for example 2, a car towing a trailer travels along a horizontal straight road. The car has a mass 1,500 and the trailer has a mass 500 kg. The resistance to motion is 80 Newton on car and 20 Newton to the trailer. Drivers apply the brakes so that the driving force replaces a braking force of 100 Newton opposite to the forward motion. Find the force in the tow bar. And the car, okay, for part A, we settle the part A first. Okay, for part A, okay, for part A, you may consider this is a total system first. Total system. Okay, total system, same things. You have the mass is total 500 plus 1000. Okay, 2000 kg. Alright, and you have a resistance 80, and you have 20. Okay, and don't forget you have a braking force 100. Okay, so you can apply the net force equation for the total system. Okay, so this is, we consider this is a total system. So to solve it, you will get A equal to negative 0.1. Okay, so this is a deceleration, right, for the system. Okay, once you've done this, then you can proceed to find the T. Okay, so for the student that don't want to use a total system to find the A first, you can separate the item, become two parts, and solve the two simultaneous equation, right? Okay, and you will also find the A also, right? Let's go to the next part, and we separate the items, see what happened. Okay, so if you separate the item, you have a T here, and same things, you have a 20 here, and this is the first week. Let's say this is 1000, this is 500. Okay, and for the car, you have 80 here, you have 100 here, and don't forget you have T here also. Okay, 3 items, so the mass is 1500, right? So in this situation, you can choose which one you want to use. Let's say I use the simple one. So T minus 20 is equal to 500 A, right? Okay, so from here you just sub down the A here, there, and you will have a T equal to 500 times 0.1 plus 20, right? So you will get T equal to negative 30 Newton, right? So negative 30 Newton mean what? So originally you assume that T is tension, right? It's pulling force, right? So the answer show you negative. Negative mean opposite direction. So for this case, it's not a pulling force, right? So when the car brake, right, the force that apply on the tow bar actually is a compression force. It's a thrust, right? It's a thrust, right? So they will have a pushing force, okay, pushing in the tow bar. Okay, when you brake, okay, it's a thrust, right? So you get the answer negative there. So this is for part A. Okay. Okay, for part B, the car then descend at a hill at 3 degree to the horizontal. The resistance and the braking force are unchanged. find the new force in the tow bar. Okay, so now the car start to, okay, now the car become a descent hill. Okay, okay, we can roughly draw the diagram. Okay, two part. Okay, C for car, this one for RT for trailer, perpendicular, this one, so resistance 20 here. Okay, and you have a T here, we assume it's the tension first. Okay, and another side here also T. You have AD here, and 3 degrees, this is 500, and the mass of a car is 1500. Okay, right, so the braking force, don't forget 100 also. Okay, so we assume this is you have a resistance to motion already. I think the question never mentioned about the friction on the platform, so we assume the platform is a smooth surface. Okay, so you have something like that. Okay, so some things you can consider the individual particles to calculate, to use the simultaneous equation to find the A first, and find the T, or you can consider this is a total system to find the A first, then solve for the T. Okay, so let us to find the A first. Okay, let us find the A first. Okay, if you want to consider this is a total system, don't forget you need to resolving the forces. Okay, so the 1500, the mass, you need to resolve to the parallel to the plane. So 150, this one is 00 mg. Okay, sine 3 plus the force that bring by the weight of the trailer. Okay, minus the resistance from the brake for the car and for the trailer. Okay, no more any other external force that parallel to the plane, so it's equal to 2000 A. Okay, so by solving this equation, you will get A equal to 0.423, right? 423 meter per second square, right? So I mean, if you use the total system to solve, right, I think the simultaneous equation is not so complicated. If you only use the simultaneous equation for separate item, right, okay, the solving of the equation will be maybe complicated a bit, but it's okay to use that also, right? Okay, so you have the acceleration for the total system 0.423 meter per second. Okay, so now you can consider the net force equation for the tension. Okay, for the separate item. So for the separate item, you may able to form two equations. The first one maybe is for the trailer you have 3 plus 5000 sine 3 minus 20 is equal to 500A. Okay, another one you have for the car 1500, sorry, 15,000 sine 3 minus 100 minus 80 and minus T is equal to 1500A. Okay, so when you have these two, okay, so just now as I mentioned, if you don't want to use a total system to find the A first, you may solve these two equations to find the A and T. Okay, it's okay. Okay, depends on you which one is better for you, right? So now once you have found the A from the total system, you may direct sub inside either one. So let's say I sub in the first one, T, just direct sub inside, T will be equal to negative 30 Newton. Okay, so by this situation, you can see that, okay, the force in the tow bar still is a thrust, right? Because negative, and the magnitude is still the same, 30 Newton, right? Although you have increased the degree of the inclined surface, right? Okay, so this is for question 2.